Hi dear students of plus one medical, non-medical and respected teachers. So today I am going to discuss chapter laws of motion. In this video I will discuss only force, momentum, definition and the units and the three basic Newton laws of motion. So first of all, what do you mean by force? In a simple way, force is a push or pull which when acting upon a body displaces or tends to displace the body in any direction. In other words, a force is that external agent which when acting upon a body produces or tends to produce acceleration in the body. Because when force acts, it will tend to change its velocity. And whenever there is a change in velocity, there is acceleration. So, force is that external agent which, when acting upon a body, produces or tends to produce acceleration in the body. So, it is given by F is equal to ma. So, force is a vector quantity. Then, what is momentum? Momentum means quantity of motion. Momentum is the measure of quantity of motion, and it is equal to product of mass of the body and velocity of the body. So all moving bodies will have momentum. So P is equal to mv. It is also a vector quantity. Units of momentum in SI system will be kg meter per second, and in CJ system will be gram centimeter per second. No special name has been given to units of momentum in SI and CJ system. On the other hand, force, units of force has special names Newton and dyne in SI and CJ system respectively. That we'll discuss later on. Then, what does it mean by Newton's first law of motion? Because these laws relate force and momentum. So that's why we define force and momentum first, and then we come to Newton's laws of motion. So Newton's first law of motion, what it states? It states that every body continues in its state of rest or uniform motion along a straight line until unless it is compelled by some external force. जब तक बाहरी फोर्स किसी बॉडी ਨੂੰ ਡਿਸਟਰਬ ਨਹੀਂ ਕਰਦੀ, ਉਹਨੂੰ ਮਜਬੂਰ ਨਹੀਂ ਕਰਦੀ ਉਹਦੀ ਪੋਜੀਸ਼ਨ ਚੇਂਜ ਕਰਨ ਲਈ, ਬੋਡੀ ਪਹਿਲਾਂ ਰੈਸਟ ਤੇ ਹੋ ਸਕਦੀ ਹੈ ਜਾਂ ਮੂਵਿੰਗ ਬੋਡੀ ਰੈਸਟ ਆ ਸਕਦੀ ਹੈ, ਰੈਸਟ ਤੇ ਬੋਡੀ ਮੋਸ਼ਨ ਚ ਆ ਸਕਦੀ ਹੈ. So that is nothing but Newton's first law of motion, that every body continues in its state of rest or uniform motion along a straight line until unless it is compelled by some external force. ਜੇ ਬੋਡੀ ਰੈਸਟ ਤੇ ਪਈ ਹੈ ਤਾਂ ਰੈਸਟ ਤੇ ਪਈ ਰਹੇਗੀ ਜਦ ਤੱਕ ਅਸੀਂ ਐਕਸਟਰਨਲ ਫੋਰਸ ਨਹੀਂ ਲਾਉਂਦੇ. ਜੇ ਬੋਡੀ ਮੂਵ ਕਰਦੀ ਹੈ ਤਾਂ ਮੂਵ ਕਰੀ ਜਾਏਗੀ ਯੂਨੀਫਾਰਮ ਵੈਲੋਸਿਟੀ ਨਾਲ ਜਦ ਤੱਕ ਅਸੀਂ ਐਕਸਟਰਨਲ ਫੋਰਸ ਨਹੀਂ ਲਾਉਂਦੇ. So this is Newton's first law of motion. It means this Newton's first law of motion is nothing but qualitative definition of force. It gives nature of force. What is force? Because force is that external agent which when acting upon a body moves or tends to move the body, displaces or tends to displace the body, produces or tends to produce acceleration in the body. So this is Newton's first law. It is nature of force. And this law is also known as law of inertia. Now what is inertia? The inability of the body to change its state of rest or uniform motion along a straight line is called inertia. So more is the mass of the body, more is the inertia. So inertia depends upon mass of the body. Now inertia is of three types. Inertia of rest, the inability of the body to change its state of rest by itself, is called inertia of rest. For example, when we are standing in a bus which is at rest, and when bus suddenly starts moving, we feel a backward push. because of inertia of rest. Because when bus starts moving, bus comes into motion, but our feet which are in contact with the bus still at rest. So that's why we feel a backward push. This is due to inertia of rest. Second, inertia of motion. The inability of the body to change its state of uniform motion along a straight line by itself is called inertia of motion. So suppose when we are moving, sitting in a moving bus, so we are also moving with the speed of the bus, with the velocity of the bus. But when brakes are applied to the bus, so bus suddenly stops, we feel a forward push. This is due to moment of inertia of motion, because bus come to rest after the application of brakes, but our body which is in motion doesn't come to rest while our feet come to rest along with the bus. That's why we fall forward. So we have to take care of it when we are standing in a bus, moving bus or train. Third, inertia of traction. The inability of the body to change its state of direction by itself is called inertia of traction. So for example, when we are traveling in a car or bus or car suddenly takes turn to the left, we feel pushed towards right and vice versa. So this is due to inertia of traction, because our body is unable to change its state of traction by itself. So this is the difference between inertia of rest, inertia of motion, and inertia of traction. Then Newton's second law of motion. Newton's second law of motion states that rate of change of linear momentum is directly proportional to external force acting upon the body, and it takes place in the direction of force. जिस डायरेक्शन से फोर्स लग रही है उसी डायरेक्शन रेट ऑफ चेंज ऑफ मोमेंटम होएगा. That is, F is directly proportional to dp by dt, or P is equal to mv. Therefore, F is proportional to d by dt mv, or m can be taken common, constant is outside, so F is proportional to m dv by dt. d by dt is nothing but acceleration, so F is proportional to ma, or F is equal to kma, where k is a constant of proportionality, but value of k is chosen to be 1 because units of force m and a are so chosen that when m is equal to 1 unit, a is equal to 1 unit, F is equal to 1 unit. Therefore, k is equal to 1 unit. So therefore, F is equal to ma. This is the fundamental equation of motion. So force equal to mass into acceleration, equation number 1. So from this equation, we can see this force F is equal to ma. It means this Newton's second law of motion gives the quantitative definition of force. This is the physical significance of Newton's second law of motion. It gives quantitative definition of force. It gives measurement of force. And first law gives qualitative definition of force. This is the physical significance of first law. So from this equation we can derive units of force. First, number 1 is absolute units. In SI system, if F is equal to 1 kg, A is equal to 1 meter per second square, then F will be equal to 1 Newton. So Newton is the unit of force in SI system. So how we can define 1 Newton? Very simple. So force acting upon a body is said to be 1 Newton if it produces an acceleration of 1 meter per second square in a body of mass 1 kg. So in CGS system, when m is equal to 1 gram, a is equal to 1 centimeter per second square, F is equal to 1 dyne. So from here we can define 1 dyne. So 1 dyne, it is that force which when acting upon a body of mass 1 gram produces an acceleration of 1 centimeter per second square. So unit is dyne. So 1 Newton is equal to raised to power 5 dynes. So we can convert Newton into dyne. Number 2, gravitational units, where value of G is involved. For example, weight, because weight is the force with which body is attracted towards center of earth. So weight is a force. So if in SI system, if m is equal to 1 kg, instead of A we take G, acceleration due to gravity, that is 9.8 meter per second square. Then F will be equal to 1 kg weight or kg force. So which will be 1 kg into 9.8 meter per second square, that is 9.8 kg meter per second square is Newton. So 1 kg weight or 1 gram kg force is equal to 9.8 Newton. This is relation between gravitational and absolute units. So 1 kg weight is equal to 1 kg force is equal to 9.8 Newton. Similarly, in the CGS system, m is equal to 1 gram, G is equal to 980 centimeter per second square, then F will be equal to 1 gram weight or 1 gram force, or it will be 980 dyne. So 1 gram force or 1 kg weight, 1 gram weight or 1 gram force in CGS system is equal to 980 dynes. This is the units of force. Then Newton's third law of motion. It states that to every action there is an equal and opposite reaction. For example, a block is lying on the table. Now this block is applying weight. Weight is acting vertically downward and its reaction is acting vertically upward. So this weight is known as action and this is known as normal action is known as reaction. But even action and reaction are equal and opposite. Action equal minus reaction, but they do not cancel each other. Question may be asked. Action and reaction are equal and opposite, but they do not cancel each other. Why? Because they act upon two different bodies. Action is applied by weight block on the table. Reaction is applied by table on the block. So for two forces, equal and opposite forces to cancel each other, they must act upon the same body. But they are acting upon two different bodies, so they do not cancel each other. So this is Newton's third law of motion. So these are the three Newton's laws of motion. So in next video, I will discuss Newton's second law is the only real law of motion. That is, we can derive first law and third law from second law of motion. So till then, stay tuned. Good luck, be happy. All the best. Sarvat Dapala.